All right. Good evening, I guess it is, and I apologize for the background noise, but I can't do anything about that. Hopefully, it's not too bad. I wanted to kind of sit down and talk with you all about a little bit about motors and drive systems in the Binsons, what the various motor types are, what they're good for, what the problems are with them, and then also some of the things you can do to try and keep your Binson operating without going through an incredible amount of warble or wow, flood, or whatever you want to call it. So what I have here is an example of just about every motor I've ever found in a Binson. We're going to start over here. So this is what's called a Lorentz motor. This runs at 165 volts and it's a 50 hertz motor. Now, every motor that I have here, with the exception of this one on the end, is a synchronous motor. And what that means is that the shaft speed is dependent on the AC voltage that you apply to the motor. The only way to vary the speed on these is to change the excitation frequency that you're using to drive the motor. In Europe, it's 50 hertz on the out of the line wall, or wall lines, excuse me. In the US, it's 60 hertz. So all of these motors, when they run in the US, they run at a 20% faster speed than they do in Europe. Is that a big deal? Is it not a big deal? It's up to the user. The only thing is, the only way you're going to reduce the speed of your drum to match the 50 hertz electrical excitation would be to machine this spindle to a smaller diameter, because at the end of the day, your drum speed is equal to the ratio of the drum diameter to this shaft diameter. Okay, so runs at 165 volts. Where does that come from? This is kind of a ratty example, but inside your Binson you'll have this power terminal strip, and it goes neutral, 110 volts, 145. I'm sorry, 110, 125, 145, 160, 220, and 240 volts. So you're going to connect that motor between the neutral and the 165 volt pin on this. Now, the way this motor in particular works is it's got a run capacitor on it. I don't have it connected to this one, but basically there's a capacitor that hangs on the side of this. It'll look like a cylinder. A silver cylinder. It is a 1 microfarad capacitor. It's full of oil, or at least it was when it was manufactured. Generally speaking, when you get yourself one of these units, as old as they are, the oil has leaked out. All right. So what's the purpose of that capacitor? Well, that capacitor, this is a 3-wire input. That capacitor creates a phase delay on one of the windings. So you actually have a 2-phase motor. If that capacitor is not working, or it's not of the specified value, or not there, whatever you want to say, that motor will not spin well. It may well start because there'll be a little bit of capacitance left there, but you're going to have torque problems. It's not going to run the Binson drive as well as it could. Now, what I have found the answer to be, these are from ceiling fans. It's a 1 microfarad capacitor, has a handy mounting screw on it, and I use these, and it brings that motor right back to life. Now, there's a set of bearings in this motor. They come on and off by spinning this flange, and there's one on the bottom. I've never done it. I don't have that kind of courage, because if you don't get it right, it's not going to work well. However, my experience is very rarely do those bearings ever go bad. So that's in a lot of the older Binsons. The next oldest motor is this example here. This is a reluctance motor, and it has 1 coil on it. This one is toast because this is burned up, but this is a reluctance motor. A lot of times they have a fan on them, which was a horrible thing to do to a Binson because all it does is suck in dirt. But at any rate, this is what's called a reluctance motor. It's another example of a synchronous motor. The difference is this is called a shaded pole, and these are a shorted turn around one of the poles of this motor. And what that does is that sets the rotational direction for the magnetic field when you plug it into the wall. You want to be careful with these because you don't want to overexcite the motor with higher voltage than necessary. So pay attention to how it's connected. I don't want to give you a panacea in terms of how to connect the device. Now you'll notice that there's some play in this shaft that'll come back and forth and in and out. There's nothing wrong with the motor. That's absolutely normal, because when you energize this motor, it's going to find the magnetic center and stay there. Okay, again, this is a synchronous motor as well, so it's going to operate at a speed proportional to the wall outlet frequency. Okay, now these guys are generally fairly reliable, except that one. That's why it's sitting here. A very, very common motor that you'll find, and this one's a part. This is another reluctance motor with a shaded pole. The difference here is there's 2 coils for excitation. For 110 volt operation, you connect these 2 coils in parallel. For 220 volt operation, these get connected in series with a wire. One feed wire goes here. This is connected diagonally to this pin, and then this is the other connection. Okay, changing the polarity of the AC will not change the directional rotation of this motor. If you want to change the rotation, you actually have to take the armature out or the rotor out and flip it over. It's the only way you're going to do that. I see no reason to do that, but I did find one that was spinning the wrong way, so somebody had some fun. Now in these motors, this is the rotor. This is a reluctance motor, so there's no turns on it. It's made up of laminated iron, okay? And there are 2 bearings. There's the bottom bearing, it's a thrust bearing, and then also here's your main spindle bearing. For this motor to run properly and not have any wow or flutter problems, you need to take these bearings, and I generally polish them again using a very, very mild abrasive, but you don't want them looking like this. And the reason this rotor is out of a motor not being used is because these bearings are pretty scored up. But anyway, these, of course, these are the bearings off of the motor. This is the bottom bearing. Okay, these are bronze. This is terribly filthy, but these are bronze bearings. They do not require lubrication. However, it's a good idea to polish them. And what I'll generally do is get a Q-tip, get some polishing compound on it, chuck it up in a drill and run it in and out of this one or the top bearing and polish them up. If there is excessive play in these bearings, in other words, when this is put together, you should not be able to wiggle this rotor back and forth. If you can, the bearings are shot and you'll need to replace the motor. Okay. Finally, the last reluctance motor that I have here, this is another 2-winding motor. This is a reluctance motor. This is out of the 303 series, or I'm sorry, 603 series of Echorec. Same basic principle, except the coils are all on one side. They're connected. Let's see, what's my color code here? So the white and yellow wires are neutral. The green and the red wires are hot. So, connect it in series or parallel depending upon your line voltage. Okay, so finally, the only DC motor that I have found in Echorec is this guy right here. This is approximately, I believe it's either an 8 or 9 volt motor. These are available for sale. They are incredibly expensive. Okay. Now this is a DC motor, and sorry about that. The DC motor is easy to do speed control because all you have to do is vary the DC input here. If it's spinning in the wrong direction, you can flip the terminals because it's a DC motor. Big difference between this and these examples here. Now, so one would think, boy, that's great, it's got a DC motor. Let me do a vary speed on it because all I have to do is provide a variable voltage drive. But here's the problem. This motor is lousy, has lousy torque characteristics at low voltage, at least in my humble opinion, and this is not a very good candidate to do a variable speed drive if you want an extremely wide range. If you want a limited range of speed variation, this is fine. However, if you really want the thing to go slow, which some of you guys want to have happen, this motor will be problematic at low speed. And it'll also pull a lot of current. You want to do that. Okay, so there's that. So finally, the last thing to keep your Echorec running at a pretty good speed. Okay, here's your drum. Okay, this is my spare drum, so gonna be careful with it as I knock everything around. But at any rate, the way this is set up is you've got a spindle, very long spindle here, that sits in this bearing. And there's a thrust bearing at the bottom. And the height of the drum compared to this is determined by the setting of this lock nut, this lock nut and this set screw at the bottom. So to clean these, what I will do is measure the length with a pair of calipers so I can put it back to the way it was. Loosen this nut, and it sounds pretty brutal, but I do it with this still mounted inside the Echorec. There's room to do it because it's hard to get enough torque on this thing to get this nut off without it mounted in something. Clean this out thoroughly. Clean the bottom. There's a ball bearing at the bottom. Make sure that is all clean. And then I will get some polishing compound on that spindle, and I will lap these together until this spindle comes out looking like perfect chrome, as does this. Now you got to be careful to not do too much of that, because if you go too far, you're going to get some play in this bearing, and that's a very bad thing. Now the other thing that you want to make sure of is that these bearings have numbers on them. Some folks claim that 60 would be the date. I'm looking on this one, and that's going to prove me a lot. Oops, sorry. This is going to prove me a liar. Okay, but there is a number etched into this drum right here, and there should be a corresponding number etched into this bearing, and here they are. So here's this. It says on here, sorry. Trust me, it says P75H. It says P75H here. They need to be a matched set. If they are not matched, you can get play in this bearing and it's not going to work right. So like I said, very important to clean this. Finally, we can talk about our drive wheels here, okay? Rubber drive wheel. Definite life on these. They need to be refurbished. You need to have nice soft rubber on here or it's not going to work well. The other part as well is that there's a bronze bearing in here, and the spindle that this sits on, I don't have it here because I don't want to clutter up the workbench that much, but those two also need to be polished, and I will lubricate that surface. By the way, I do lubricate this as well. I try not to use a heavy grease because heavy grease has a tendency over time to turn into glue, which is not, what you're going to want. So I will use a heavier oil. I use Singer sewing machine oil on the wipers and so forth. But for this, I'd like a little bit heavier of an oil. Okay? So, keep your bearings clean. Keep your rubber wheel nice and soft. It'll work great. If you want a very limited speed, this motor is fine. I would replace it, however, with a motor that has a decent torque characteristic at lower speeds. For example, like a model train motor. It's going to be noisy, but it's going to be rock solid on speed, especially at low speeds. Okay? These other motors are synchronous motors. You cannot vary their speed. They're chained to your line frequency. If you want to match a European and you're goofy enough to do it, you can, I shouldn't say that. If you really want to do it, you can machine these down if you know what you're doing with a lathe, understanding the ratio of diameters, and then you can slow your Binson down. So I hope that was useful for you. If you're going to go buy a Binson, I wouldn't worry so much about the large Lawrence motors. But what I would do on all of these is wiggle the shaft around to see if there's any play. Look and see if you have discoloration like this on this particular motor. Clearly it's been toasted. Make sure there's no play, and understand that if you do have the black Lawrence motor, you're going to have to change that capacitor, which is a very cheap and easy repair. So again, bearing play. Then when you get it back, obviously if the thing's running great, don't touch it. But if you're concerned about your speeds, start here. Make sure this is all nice and clean. You have a good rubber wheel, clean bearings with well lubricated bearings, and then potentially you might have to look at your motor. So anyway, I hope this was I hope this was helpful, and I promise to make more videos on other Binson aspects in the future. Meanwhile, thanks for watching, and if you want to hit me with questions, by all means. I try and look at the comments as often as I can. Have a good night. Take care.